Moving from a single prompt and response AI to a system where multiple autonomous agents operate independently exposes a severe computational bottleneck. Traditional hard-coded logic loops break down quickly. When autonomous agents must continually negotiate tasks and consume compute resources without human oversight, linear state machines cannot scale to manage the complexity. The ALCAT architecture proposes a structural fix for this state management and resource allocation bottleneck. It discards standard programming loops entirely. Instead, it drives agent behavior using a deterministic cellular automaton, secures the data with post-quantum cryptography, and funds the required compute through direct machine-to-machine micropayments. Efficiently managing agent swarms requires merging distributed systems engineering with cryptographic settlement. Setting up the ALCAT environment begins at the local level by spinning up a basic server node. This chart maps the 4 core pillars of the system: the human interface for initial input, the agentic automaton for execution logic, zero-trust security for compliance, and monetization for continuous funding. To understand how these components interact, we can trace a single autonomous task from a human prompt through the entire execution pipeline. Every data payload must successfully clear 4 distinct routing stages to succeed: state generation, compliance, cryptographic signing, and final settlement. Testing this structural logic requires sending a request directly to the system's orchestrate task endpoint and observing how these disparate protocols hand off control. The trace begins when the API receives a prompt, instantly instantiating a 4-agent Conway swarm to parse the instructions. This 2D cellular automaton uses the Conway rule set. 3 active cells spawn a new one. Those with 2 or 3 neighbors survive. ALCAT uses this entropy to dictate logic. When the grid hits a stable geometry, it acts as a switch, shifting the agent from discover to negotiate. Relying on a mathematically deterministic automaton yields a state engine that is highly resilient and strictly auditable, preventing autonomous agents from getting stuck in the infinite processing loops. Before any negotiated action can execute, the packet hits a compliance checkpoint, where it is verified automatically against Coinbase KYC records and active OFAC sanctions lists. Once cleared, the task advances to the sign phase, requiring a cryptographic authorization to guarantee the payload's integrity. Current encryption relies on the computational difficulty of prime factorization, models like RSA. These are highly vulnerable to the rapid decryption capabilities of Shor's algorithm, running on a powerful quantum computer. This illustrates the shortest vector problem inside a multidimensional lattice structure. ALCAT applies this to implement NIST-FIPS standards, specifically ML-Chem 768. The action payload routes through this matrix, is encapsulated by lattice vectors, and emerges cryptographically locked with a quantum-safe signature. These rigorous cryptographic frameworks originate directly from the physical standard-setting laboratories, driving the global transition to post-quantum infrastructure. Applying lattice-based cryptography ensures that commands executed by autonomous machines remain secure against inevitable hardware advancements. The final requirement in the execution sequence is settling the cost of the computing power the task has consumed. This sequential chart tracks an active HTTP intercept. The server rejects the payload with an RFC-compliant 402 payment required challenge, stalling the final execution phase until the debt is cleared. To resolve this roadblock, the system leverages the Algorand X402 protocol for an immediate micropayment. A gasless sponsor relay injects the necessary transaction fees from external node, instantly converting the rejection into a green 200 OK block. The cryptographic proof of this atomic settlement satisfies the final execution requirement, releasing the payload for autonomous execution. Forcing the financial settlement to occur directly within the HTTP header response removes the friction between data transfer and economic exchange. This packet's lifecycle spans fractions of a second, originating in geometric states, receiving a quantum-proof signature, clearing a microtoll, and executing on the open network. The platform is built with resilient offline sandboxing, allowing the UI and cryptographic signing modules to function securely without external API connections. For broad deployment, the architecture relies on Arbitrum stylus Rust contracts to audit logic, paired with Netlify edge artifacts to guarantee rapid global distribution. This infrastructure is sustained through integrated monetization via RevenueCat. The ad-supported catvertising free tier introduces users to the environment, while the Pro Agentic tier unlocks unlimited agent orchestration via monthly fiat subscriptions. For large-scale Web3 protocols and financial institutions, the Quantum Enterprise tier provides dedicated hardware enclaves and continuous OFAC sanctions monitoring. The ALCAT architecture integrates state logic, zero-trust security, and payment into a single protocol stack designed specifically for machine-to-machine economies.